This video was brought to you by Embedded System Solution, a company composed of like-minded electrical engineers, computer engineers, and computer scientists, and whose main goal is assisting our engineering customers, non-engineering customers, and technician level customers with their electrical and computer engineering level and technician level needs. Our customers range everywhere from engineering students to university professors, technicians to engineers, junior engineers to senior engineers. Please feel free to visit us at www.embeddedsystemsolution.com. Again, www.embeddedsystemsolution.com, or better yet, email us at support@embeddedsystemsolution.com. And like always, don't forget to subscribe to our channel and like. Okay, I'm sorry, I'm creating this video again because there was so many interruptions. But I'm going to talk about hashing because I feel that hashing is very important for you to understand the concept. So in terms of authentication, right? And so hashing is something that's seen everywhere. It's seen especially whenever you're entering passwords, storage of passwords. It's what's used. It's what ensures that hacking is very difficult. So we talked about. I don't know if you've seen that video, right? But if not, go back and see it. We talk about the Linux shadow file and how is it that it stores the hash value of a password. So, but what does the hash value of a password mean, and why do we do it, right? And so you have to be wondering, right? Like, think about when you barely were introduced to a computer. I don't know if this is something that you ponder. Maybe you were introduced to a computer when you were so small that you didn't even bother knowing, and you didn't bother caring. But I remember when I was introduced to a computer. So think about it. A computer admin creates an account for you, right? And normally, he puts a simple password, and you have to change that password, right? Let's suppose his password is password 123, and you're expected in the first login to change your password. And so you get into your computer, he creates the account, then you take over and you enter your password, right? So you're like, this is what I want my password to be every time I log into this computer. So it has to make you wonder, at least it did to me. So that password that you're entering when it's creating the account, it has to be stored in the computer, right? So whenever you log in again, maybe within 5 minutes, 10 minutes, or every time you log in, the computer asks you for a password, correct? That whenever you log in, you have to compare that password to an existing password to determine whether you can log in or not. And that existing password is the password that you created whenever the account was created, right? And so if they match, then you're allowed to log into the computer, correct? Well, if you think about it, I have to if that password in terms of Linux, whenever you create the account, the password is stored in the shadow file. So it has to make you wonder, hey, if someone gets access to this computer where I enter my password, and there's a comparison, there's already a stored value of my password in that computer, then doesn't that mean that somebody can, if they have access to that computer and they somehow locate the point where get the location in the file system where the password is saved, can't they extract the password and use it for other illicit means? Because tell me that I'm not lying. Tell me, I bet you that your bank online, Bank of America, Wells Fargo, your what is the other one? Your stock, your retirement, for every single one of those websites, do you not create the same username and the same password? I bet you do. Only because as humans, we struggle with memory. So it's just easier for us to create one password, one username, and use that for all of our accounts. So going back to what I was talking about, if they hack that computer, if they locate where the stored password when the account was created, if they can locate where it's at and they can extract it, doesn't that mean they can hack other computers, other accounts that you have? Well, at least that's what I wondered, right? It turns out you can't, and the reason why is hashing. So there's a whole bunch of hashing algorithms, but in simple terms, hashing is a simple function. It's a one-way function, actually, where you have an input and it produces a predictable output, right? So like I said, Google this online hashing generator, right? And so you see MD5. Now, I clicked on this one and I also clicked on the one on the bottom, correct? So we have one here and the other one here. Now, because they're both the same algorithm, MD5, watch what happens if I put the letter A in this one. It generates a hash value, correct? So I'm going to store it. So I'm going to store this, right? So this is the plain text password, and this is the hash value, right? And so that's the hash value, and we enter the letter A, right, from this website. Okay, so now we're gonna go to this other website, and again we're gonna enter the value, and guess what? Produces a hash value. So this is the input. Now let's strip away all the tags that it has. Hey, what the heck? From two different websites, I put in the letter A and they both gave me the same output. It's the same hash value. Well, like I said, hashing algorithm is a predictable output given the same input. So it doesn't matter which website you use, as long as they're using the hash MD5 hash algorithm. If you put a specific input, it will generate always the same output. So that's a key thing. So if you're new to encryption, or you're considering, majoring in encryption, or you're just curious about this, it makes you wonder. It's like, wait, isn't encryption publishing how you're doing it? Isn't that opening yourself up to hacking? It turns out it's not. Like whenever I was learning encryption, I thought obfuscation was better method. And so when I saw that everything was openly published, I'm like, how is it that if hackers know the algorithm, how is it that it's so hard to hack? How come is it that there's not many more hackers than there are? And the reason is the mathematics behind it. Encryption and hashing is something that's very fundamental. And again, one of the fundamental things is given the input, there's always a predictable output, right? And so that's concept number one. That's observation number one, right, about a hash. The second thing is, now we're going to enter as a plain text. It doesn't matter which website we use, right? Now we're going to enter as an ASCII value. So again, I forgot to mention this, but these are ASCII values. So as an input, you can enter either an ASCII value or a whole file. It doesn't really matter, but I'm getting ahead of myself, right? So now we're going to enter the ASCII value B, and we're going to ask it to generate a hash value, correct? That's the hash value. We're going to copy it. Again, I'm going to strip out all the tags that it has, copy it. Then for the plain text for the ASCII as a password, I put the plain text ASCII letter B, right? Now look at the hash value. That's the second observation from a hashing algorithm. Hopefully you've noticed it, or at least I at the same, again, whenever I was learning this, I was thinking the hash value of the letter A should be somewhat similar to the hash value of the letter B. After all, they're right next to each other in terms of the alphabet. But if you notice, the hash value of the letter A has absolutely nothing to do with the hash value of the letter B. And that's done on purpose. That's another observation from a hashing algorithm, that given the input, even if the following input is somewhat similar, the hashing value has to be completely different. And that's something that you see. So instead of the ASCII character, we're going to extend this a little bit more, right? Instead of inputting an ASCII character to a hash algorithm, we enter a file, right? Think about it, a file, just a regular text file. And that file happens to is 1,000 bytes long, right? Yeah. And we enter to that. So yeah, so we're entering a file to the hashing algorithm, which is 1,000 bytes long. Then, as an input to the hashing algorithm, we put another file, which is 1,001 bytes long. But the first 1,000 bytes are the same as the previous file. The only thing is we added something, a letter and